We all have these little magic boxes in our pockets, right? They let us talk to anyone, anywhere, even when we're speeding down the highway. And it just works. But behind that totally seamless connection, there's this incredibly complex, high-speed process going on. So today, let's pull back the curtain on the invisible relay race that makes it all possible.
No, really, just stop and think about it for a second. You're in a car, moving fast, and your phone is having a constant conversation with a stationary tower. How on earth does it maintain that perfect connection when you fly out of one tower's range and into another's? I mean, it feels like magic, but it's actually just a really, really brilliant piece of engineering.
And the hero of our story today is a process called the handover. This is the secret sauce. This is the thing that makes sure our digital lives don't just come to a screeching halt the second we start moving. It's the mechanism that keeps your call, your music stream, your data just flowing without a single hiccup.
Okay, so let's break down the fundamental challenge here. How do you maintain a perfect, totally uninterrupted connection to a device that's constantly on the move? It's actually a way harder problem to solve than you might think.
The best way to think about this is like a relay race. Your phone is the runner, and that precious connection, that's the baton. As your phone moves from one cell tower zone to the next, it has to execute a perfect baton pass. The whole goal, as researchers put it, is making sure the best-serving tower is always the one you're connected to.
Now, the simplest version of this race is what we call a horizontal handover. This is a really straightforward baton pass between two cell towers that are pretty much identical using the same tech. It's the most common type of handover you and I experience every single day. But what happens when the race itself completely changes? Well, that's a vertical handover. In this case, your phone isn't just switching towers, it's switching technologies altogether. Think about when your phone automatically jumps from the cell network to your home Wi-Fi the second you walk in the door. It's like a runner having to switch from the running track to a swimming pool mid-stride. Way more complex.
So, for decades, we've gotten really good at this relay race. But then, 5G came along. And the demands that 5G puts on the network are so immense, so completely different, that they basically threaten to break this beautiful, elegant system entirely.
Just let this number sink in for a moment. 10 million. Future networks are being designed to handle 10 million connected devices per square kilometer. And we're not just talking about phones. We're talking cars, watches, streetlights, tiny sensors, literally everything. Our nice, simple relay race is about to get unbelievably crowded.
And the result is something called an ultra-dense network. So it's not a clean track with a few big towers anymore. No. It's more like a chaotic, packed stadium with millions of runners and tiny short-range cell towers absolutely everywhere. The baton passes become constant, frantic, and they're all happening at once.
And here's the crucial point. All that density creates huge problems. With all these smaller cells, you have to do handovers way more often. All those signals start interfering with each other, and this can lead to something called the ping-pong effect, where your phone just rapidly switches back and forth between two towers, which creates instability and, yep, you guessed it, dropped connections.
And the challenges don't just stop with how crowded the network is. The future we're building is placing demands on these networks that push the handover process to its absolute breaking point, creating some really mind-bending problems.
Yeah, you were seeing that right. Future networks need to support devices moving at up to 1,000 kilometers per hour. We're talking high-speed trains, maybe even futuristic transport. At that kind of speed, the handover, that baton pass, has to happen in a tiny fraction of a second, or the connection is just gone.
And another huge challenge comes from the tech itself. See, to get those insane 5G speeds, we're using new frequencies called millimeter waves, or mmWave. But there's a pretty stark trade-off. While they give us incredible speed, these signals are also extremely fragile. They have a very short range, and they can be blocked by almost anything: a wall, a tree, even your own hand. This just makes choosing the right tower and timing that handover perfectly even more critical.
So what if we just got rid of the relay race entirely? Well, that's the wild idea behind self-free networks. Instead of your phone handing off the baton from one tower to another, it's connected to a whole team of smaller access points all at the same time. The handover problem just vanishes, but it gets replaced by a new, incredibly complex challenge. How in the world do you coordinate that entire team of access points in real time?
Okay, so the old system is breaking, the challenges are absolutely massive. So how do we solve this? Well, the answer isn't just throwing more hardware at it. It's about making the entire network smarter, faster, and way more predictive.
A huge part of the solution is the evolution in how these handover decisions are made. The old way was super simple. Your phone just latched onto whatever tower had the strongest signal. But as we've seen, that's a pretty dumb rule in a complex environment. The new way uses things like AI and fuzzy logic. The network now looks at dozens of factors: your speed, your direction, how busy different towers are, even the type of app you're using, to make a really intelligent, predictive decision.
So the toolkit for the future of connectivity is this powerful mix of technologies. You've got AI that can actually predict where you're going and get the network ready for a handover before you even need it. People are exploring blockchain for ultra-secure and lightning-fast authentication when you switch networks. And, like we saw, cell-free networks are trying to get rid of the handover problem altogether.
So why do we care so much? Why are we dedicating so much brain power to perfecting this invisible little process? Because getting this right, well, it unlocks the foundation for our entire connected future.
Believe me, the stakes are so much higher than just preventing a dropped call on your commute. We are building a world that completely depends on constant, instant, and ultra-reliable connectivity.
This is why it matters. Flawless handovers are what will let a fleet of self-driving cars talk to each other and the road without a millisecond of delay. It's what will give a surgeon the confidence to perform a remote operation from thousands of miles away. It's the key to a world where billions of smart devices are always on, always connected, creating this truly global, intelligent network. So in the end, it all comes back to this invisible, high-stakes relay race that's happening billions of times a second all around us. It's not just some nerdy technical detail. It is the fundamental enabling process for the connected world we're all so busy building.
Which kind of leaves us with one final thought. We have this bottomless appetite for more connection, more speed, more data. But as we race to connect every object, every car, every single person, the big question is, can we build networks that are actually smart enough to handle the world we're creating? Thanks for watching.